rating set. So if you call this degree delta, and if you call the number of variables n prime, then hitting set is something like 0 dot dot delta raised to n prime. That's a simple observation. So just delta plus 1 many field elements and try out all these possibilities for all the variables. Right, so this is delta to the n prime sized HSG. So here it's actually even easier. You don't need to invoke sparse PIT, but that also is true. That will need more work. Any questions? Fine. So then then we will do a similar calculation for depth 4 PIT. We'll show that if you can design HSG for depth 4, then you can design the same HSG for general circuits. So we'll do that result, and we will maybe, if we have time, we'll do this sparse polynomial HSG. Okay.
Swayam Prabha, Digital India, Educated India.
Alright, in the previous video, you would have seen the outline of our play method. So, what is the game? We have seen the outline in the previous video. Maybe let me just give you a very quick summary. We have two players, each have been given 0 points initially, and there is a variable turn to alternate their turns. The computer would randomly pick a word from the list of words it has, jumble it, and then pose the question. Based on whose turn it is, the player is supposed to guess the word the computer has in its mind. He has to give his answer. If that is exactly matching with what the computer has thought, his point will be increased by 1. Else, he would be notified of the correct answer and there is no change in his points. And the next thing is, you have to ask if the player wants to continue the game or not. Even if one player says, I want to quit the game comes to an end, because this is a 2-player game. So the game comes to an end. So once the player says, I want to quit, you need to update them of the status till now, thank them for their participation, and then you quit the game. This is what is the outline we have seen till now. I said there is some missing gaps in the previous video. I hope you would have sensed the gap. Let us try fixing it. If you would see here, the turn value is initialized to 0. Then if it is even, it is player 1's turn, odd is player 2's turn. But where have I updated the value of turn? I haven't. So that should be done. That is a missing gap here. Observe the indentation. It has to be exactly indented with this one. If turn mod 2 equals to 0. That is, once one turn is done, you have to increment the value of turn. You have to increase it. Turn is equal to turn plus 1. So you have incremented. Please observe the indentation. This is in column 9 as well as this is in column 9. Fine. So indentation is fine. So now the play method is over. So I have what it does is, as I had given the outline, everything is perfect, and once a player's turn is over, the value of turn is incremented by 1 so that the next player can take his turn. So if you would try run it, on turn equal to 0, it is the player 1's turn to play the game. Then turn value is increased. So now the new turn value is 1. So this is the turn of player 2. At 2, it again goes to player 1. At 3, it goes to player 2. So at every value of turn which is an even number, player 1 gets a chance to play, and at odd values, player 2 get a chance to play. This is how the game goes. But the program is not yet complete still. The first thing is, here we have said choose a word. So here the computer has to choose from here. Let me say define choose. So this is this is something we want the computer to do. Basically, it will have some list of words. So now let me start off with some random words, some random English words. Let me say then programming. This may be some word. Then mathematics. Let us move away slightly from academics. Player, this is a word. Condition, this could be a word. Reverse, this is some word. And 3, 5, 6, 7, 8. So maybe let me have 2 more words. Let us make it a list of 10 words. Let us just make it for now. You may have any number of words. That's never a problem. You can increase it even to 100 words, 1000 words. You can have. If you have lot of words during the continuous playing of the game, it will be fun because there is a lot for the computer. There is a lot of choice for the computer to choose a word. So it will pick any word. You can get anything. It will be fun. So let me say water. Maybe this is a word. Then I would say boat. Let me say the word boat. These are the words I have. Just some random words I have given. These are the list of words. So from this list of words, it has to randomly choose a word. So for randomly choosing, there is a built-in library called random. Let me import it. Import random. I have imported the random library. Now I can use what are all the functionalities defined in the library. So I would say random.choice. I said randomly you need to choose from this list. So the default functionality for it is random.choice. So in that random library there is a function called choice which will pick some element from a list. So words is a list of our words. So we have to pick something from a list. So let me say pick equals random dot choice. This is a predefined function, random dot choice from the list of the words. So from this list of words you pick a random word. That is what this line means. So after the word is picked, just return this pick. So now if you would see choose, you say choose. The control would come here. It sees the list of words. Random dot choice of words. It sees this command, so it picks a random word from this list and returns that value. That returned value is taken as the picked word. That is assigned the picked word. So this is how the picked word thing works now. So we have fixed this, and then something which is not defined to the computer is jumble. Let us do that now. Okay. I have to define jumble. Jumble a given word, let me say. You have some word is given to you, you have to jumble that word. Or that is nothing but you are shuffling the word, or you are rearranging the letters. That's what you are doing. So for this as well, you have something in random library. You have some functionality. It is called random dot sample. So you choose some words from this word. You choose some letters from this word. How many letters you are supposed to fill? So maybe I need all these letters. So length of this particular word. So why do I do this? I need to choose some number of letters from this word. How many number of letters? Basically all the letters I need to choose in some random order. I need to choose all the letters in some random order. Say for example, let us take one word, water. W-A-T-E-R. There are 5 letters and 5 positions, blank positions for our shuffled word. I need to choose some letter from these 5 letters. So from the 5 letter word, consider all the 5 letters, but the thing is you pick any one letter in a random order. So maybe I may pick T. So T is assigned in the first position. Then for second position, from the remaining, I will pick one letter. Maybe R. So on. This is how a random word would be generated, and this would be returned as a list. But what we need it as? We need it as a word. So the list is nothing but it would return as, for example, water. Let me say T-R-A-W-E. This is the way it has picked the letters. T-R-A-W-E will be the 5 elements in a list. But we want to merge those 5 elements, those 5 characters, and make it as a single word. So we are basically, what we want is we need to join those things. So for doing this, there is a functionality called join. So maybe I would say join these things. Join these things. And for this join functionality, we will generally give a separator. That is, in case you have a space, you terminate your join there, something like that. Maybe if I would have some words where there are some spaces, you terminate there. Terminate at the place where you need. Basically, if you would have learned about string tokenizer, this just sounds as a complicated terminology, but that's very simple. Nothing but if you are, I'll just give a simple example. There is some sentence that has been given to you. You need to count how many words are there in the sentence. How would you do that? Count the number of spaces. The space acts as the separator between the words. So counting the number of spaces will give you a hint on how many words are there in the sentence. So something like that, the space acts as a separator. So some separator has to be given based on which the joining has to occur. That is, when as soon as you see the separator, you perform this operation. You perform the join operation. Here, I don't want to see any specific separator, maybe a space or a comma or a full stop. On seeing that only, I want to perform this operation. I don't want something like that. So let me just give the blank character. Just blank character dot join. That is, don't see anything, just keep joining the letters. So T-R-A-V-A-W-E is the order I just randomly said. So just keep joining them. Just take T, again just keep joining R, take the next letter A, join, take the next letter W, join, take the next letter E, join. This is how this particular functionality works. So this is basically a separator. In case if I give some other separator, what could happen is only on seeing that particular separation, that separator, this particular operation would be starting. So I don't want that. I want that to be happening irrespective of whatever be the character. So I will just give a blank character there. This is the syntax that has been defined. So we are following it. So let me say this is my jumbled word. So after every individual character has been joined, I get back a word. Let me call that word as the jumbled word. Alright. So once jumbled word is obtained, you return this jumbled word. Alright. So this jumbled word is nothing but your question here. So when you say question is jumble of big word, the word is taken, the letters of the word are shuffled, that is the letters of the word are separated and they are randomly picked, and you get a list. You join the elements of the list to get back a single word and you return that single